This is the OFI Testing Equipment Permeability Plugging Tester, or sometimes called a PPT, also known as a Permeability Plugging Apparatus, or a PPA. Some people refer to it strictly one way or the other. It really doesn't matter. You can call it whatever you want to. This is a modification of the standard conventional HTHP filtration test, and this utilizes the 500 mil high pressure heating jacket and cell. And the modification was made by our friends over at Chevron back in the mid to late 1980s. And the reason for doing that, they noticed that when they were testing field muds that had low gravity solids and high gravity solids, or cuttings and barite, if you will, in the cell, during their hour heat up time, the particles, if there wasn't sufficient viscosity to prevent settling of those particles, the particles would end up on your filter medium. And a lot of times people ran these tests using these ceramic discs that used to be called a Loctite disc, but these ceramic discs have a thickness of 1/4 of an inch. And the beauty of this is that you can get them in varying permeabilities and porosities, up to about 180 micron mean pore throat size, and down to 10 microns mean pore throat size, and several different sizes in between. So the idea of that is that you match the permeability or porosity of the formation that you're drilling through when you run your filtration test. This is much more meaningful, gives much more meaningful data than the Wattman 50 paper does at an average pore throat retention size of 2.7 microns. So if you start off with, in this case, these are 50 micron discs, which we supply with the permeability plugging tester. If you start off with a 50 micron disc and you have a bunch of particles settling on your 50 micron disc, well, you may have a 20 micron or a 10 micron disc by the time you finish your hour heat up time due to the particles settling in gravity. So to get around from the negative effects of gravity, they came up with the idea of putting the filter medium on top. So your particles go this way. When you hit it with pressure, you're flowing through a disc that has not been contaminated by particle settling. So it gives you much more meaningful data. Additionally, you're filtering up. You're trying to measure the amount of plugging that's taking place in your system. The permeability plugging tester is a very appropriate name for this device because you're measuring the amount of plugging that takes place in your downhole formations. One big reason for using this test is we call return permeability test, where you flow through the disc in one direction, you deposit a filter cake on the bottom side of the disc, you open the cell, you flip it open, leaving your filter cake in place, you rerun your test and see how much different amounts of filtrate that you collect. If you collect 20 mils of filtrate the first time and you collect 18 milliliters the second time, you've not damaged the formation. However, if you collect 3 or 4 milliliters of filtrate the second time, you have damaged or plugged up the formation. So that's one big reason for running this test. Additionally, people will run a differential pressure greatly in excess of the 500 psi as dictated by the HTHP folks in the API. The classic HTHP test is 600 on top and 100 on your back pressure receiver. With this device and the threaded cell caps, you can go up to 4,000 psi. So it's conceivable to have 3,000 psi on your inlet pressure on the bottom, and you can have 600 psi on the top. You can have a 2,400 psi differential, and that's typically the way people run this apparatus. They use it for severe testing principles as far as filtration goes. You can use the OFI PPT in a conventional manner, however. If you want to pressurize from the top, if you want to put your filter medium on the bottom, there's nothing that says you cannot do that. Most people, when they do that, however, they purchase an additional 100 mil receiver. When you're filtering up, you use the 100 mil back pressure receiver in an upside down fashion. The taper, which normally is on the bottom, in this case is on the top, and here you attach your CO2 pressuring assembly to provide your pressure for your back pressure receiver for this device here. And you collect your filtrate out your elbow, out your barbed drain tube here. Well, if you're going to filter down, you've got two choices. You can buy another one of these in the conventional downward filtration manner, like such, with your outlet valve here and your taper on the bottom, or you can purchase just this one and replace this and this every time you want to use it in a downward manner. Most people choose not to do that. They'll buy a second 100 mil receiver, and when you do that, then you can pressure down if you want to use it as conventional filter press. You can put this device on top and use it for your permeability plugging test apparatus. So with the OFI assembly, you can do it both ways. I mentioned the cell caps. The high pressure cell caps go to 4,000 psi, and if you can see, they are threaded. The way we do this, this is an unbroken metal to metal contact area. This gives us the added pressurization capability. With using the 6 set screws, you've got 6 metal to metal contact points keeping that cell cap in place. So the set screw cell caps are rated for 2,000 psi, whereas this unbroken metal to metal surface lets us go up to 4,000 psi. The inlet cap is bare. It has no screen attached. No screen is necessary. The outlet cell cap, if we're using ceramic disc, which is typically what is used with this filter press media, the cell cap has scribed lines in it. These are flow channels. If you put a cell cap that has no scribed lines and you put a ceramic disc on top of it, there's no room for, or little room for, the liquid to flow from the outer regions of the filter to the hole in the center of the cap. So for that reason, OFI has flow channels which facilitate that, and as far as I know, we're the only ones that do have this type of cell cap, and it is highly, highly recommended that you use that, because it will change the amount of filtrate collected. If you want to use a screen and you want to use a filter paper as your filter medium, we have extra thick cell caps that you can use, or you can use a spacer. Hopefully you can see the difference in the cell diameter here. This is an extra thick cell, and it is 1/4 of an inch thicker than this one. That takes up that 1/4 of an inch space that your ceramic disc would use. And when you're using this conventionally with filter paper, you want to replace your orientation. Your scribed cap you'd use on the inlet side. On the outlet side, you'd use the flat cap with a screen, which we supply you. Over that screen, you would put a 1/4 inch thick spacer, which takes up the place of the ceramic disc, and it has its own O-ring seal as well. There's another way to do that. You can use the extra thick cell cap if you don't want to use the spacer. So we give you two ways of doing it using filter paper, either with an extra thick cap or with a spacer. Your choice. And I don't know, people use them both ways. But these cell caps are a little bit tricky to use, but not really difficult. Once you've used them a few times, they're really no more difficult to use than the set screws. And a lot of people find them much safer. If there is still pressure on that cell, you're not going to be able to unscrew that cell cap. So it has its own built-in safety factor that you don't get with set screws. And I will demonstrate as far as screwing it in later, but basically the main thing you want to do is get the O-ring seal all the way below the lip. you use a spanner wrench, which mates with the holes in the top of the cell, and you use a strap wrench. This strap wrench is not really difficult, but you just take the strap, you insert it through the hole here, like so, put this around the cell, tighten it down, and that enables you to anchor the cell when you're tightening the cell cap and or removing the cell cap. The piston that we have here, this piston separates the hydraulic fluids, which is what we use. We use a hydraulic hand pump to pressurize the particular cell. And the piston separates the hydraulic fluid from your test fluid. It has two O-rings. These two O-rings prevent the mixture of the two fluids. The long handle T-screw enables us to position the piston in place. We want to start the test off with this piston sitting right flat smack up against the inside of the inlet cell cap. And I will cover that when we get into the installation procedure. The hand hydraulic pump is operated, that's very easy to operate. You can see it here. There is a valve here. When the valve is tightened in a clockwise fashion, then you can apply pressure to the cell. You release that valve, and that immediately lets hydraulic fluid flow back into the pump. This hand pump is capable of generating 10,000 psi. So there is somewhat of a potential hazard there, and we get around that hazard by having a safety bleeder valve. This device right here. In this particular case, is rated to pop off at about 4,200 psi. Our 2,000 psi units, they're pop off at about 2,200 psi. We're the only ones that have this safety feature on our permeability plugging tester, and that is a good device to have. This is the hydraulic entry line. This is a ball valve, and as with all such valves, when the handle is parallel to the tubing, that will allow fluid or gas, whatever, to flow by. When you turn it 90 degrees with respect to the tubing, that seals it. So this would allow liquid to flow in. This is the gauge that tells me what pressure I am applying to the cell. And once again, I'm pressuring up from the bottom. This is a quick connect. This quick connect goes onto the inlet valve stem, and that has to go on very, very precisely. If it doesn't, then you won't get pressure into the cell. So basically, that is the initial setup of the OFI permeability plugging tester. And I think I've covered most of the bases. This is the heating jacket. It's the same heating jacket we use on our standard 500 mil HTHP. The temperature knob is here. These are rated 1 through 10. As with all high temp units, you have to know how hot number 3 is, and most people have a magic marker and they'll write out 140 F. And number 5 may be 240 F. And number 7 may be 350 F. You would write that on the surface. And each HTHP filter press is different, so you need to make that assertion yourself with your own particular filter press. The knob here is a cell rest plunger, and with this we can place the cell in position, and I'm going to adjust the camera a little bit. With this we can adjust the cell so that when this is in, the top of the cell assembly is positioned above the heating jacket. The fluid, if there were any inside, the liquid would be heating up. And I can install my filters, my filter medium, my ceramic disc. I can install my outlet cell cap. I can tighten it, and then remove this and lower it down into the heating jacket completely. So this cell rest plunger enables us to better be able to set up the system. So that's pretty much it. You get extra O-rings. You want to make sure your O-rings are in good shape prior to running the test, and I will cover that in the next segment of this procedure, which will be the initial setup for the OFI testing equipment permeability plugging tester. Thank you.